Okay, now that we're a little bit more familiar with logarithms and the different rules and how to expand and how to expand them and condense them, we're going to start looking at solving with logarithms, and we're going to kind of go through this process of the more simpler ones with the one-to-one property, and then we're going to move on to more complex problems. So I'm going to start out. Here's a nice simple problem to solve, and what we're going to do is we're going to work with the one-to-one property in the next couple of videos on how we can actually use this to actually solve log equations. So here I have log base 2 of x plus 5 equals log base 2 of x plus log base 2 of x minus 3. So what we want to do before we try to solve this is we want to go ahead and condense this down. We want to get this to a log base 2 of something equals a log base 2 of something, because at that point I'll be able to use that property of equality or that one-to-one property. So I don't have to do anything on this side because it's already a single logarithm. So I have log base 2 of x plus 5 equals, and I know I'm going to have a log base 2. And I look here is that, well, between these two log base 2's, I have a plus sign. Well, that plus means multiply. So that means I'm going to multiply my x and my x minus 3. So I have x times x minus 3. All right. At this point, we're ready to actually solve. Because what we can actually do, we can use the property of equality. We know that this side has to be exactly the same as this side. Well, this and this are already exactly the same. So a lot like with the exponents, when we're using the one-to-one and we set the exponents equal to each other, we can actually set what's on the inside of these logarithms equal to each other. So I have x plus 5 equals, I'm going to go ahead and distribute it, x squared minus 3x. All I did was I distributed it right here. All right, well, at this point, I'm just solving a quadratic. We're back into Algebra 1, Algebra 2. We're going to go ahead and move everything over. So I've got 0 equals x squared minus 4x minus 5. And then this does factor to x minus 5, x plus 1 equals 0. We use our zero product property. X minus 5 equals 0. X plus 1 equals 0. Therefore, x equals 5. And x equals negative 1. And at this point you think, yay, I'm done. I've got 5 and negative 1. But not quite. The reason why I say not quite is because we have to remember that if I have log of any base of a number, this c is going to be a real number. It's an element of the real numbers. But c has to be greater than 0. So initially I look at 5 and I think, okay, well that could work because it's greater than 0. But what I've got to do is I've got to plug them back into each one of these and make sure each one of those is greater than 0. So here if I put 5 here, 5 plus 5 is 10. Good. Well 5 is greater than 0. And 5 minus 3 is 2. So all of those are greater than 0. So this one works. If I put negative 1 here, negative 1 plus 5 is still 4. That's okay. But I put a negative 1 here. Negative 1 is not greater than 0. This is what we call an extraneous solution. An extraneous solution. So the actual answer to this question is x equals 5. Even though we get negative 1 in, we get negative 1 to solve the algebra equation, not the log equation, and we're trying to solve the log equation. So we have to check to make sure when we do the math, everything in here is always greater than 0. If it isn't, it's called an extraneous solution. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.